Hey there, it's Mr. Alexander, and today I want to talk about IB subtopics 6.5 through 6.7, which are all about drawing and interpreting graphs. Now, the first question I'm going to do is about interpreting graphs. It says the graph represents the temperature in degrees Celsius of some coffee after Manuela has heated it. Part A is write down the two variables represented in this graph. Well, that's just your x and y axes. That's time and temperature. Part B says write down the initial temperature of the liquid after heating. The initial temperature is when T equals 0. So I'm looking up here, and it's not really, let me zoom in so I can show you this a little bit closer. It's not really clear if this thing's crossing at 100 or just below it. But there's 5 boxes between 80 and 100, which means each little box is worth 4. So it's 84, 88, 92, 98, 100. So I'm not quite sure if this thing's crossing at 96 or at 100. So, I mean, just use your best judgment. I'll just write 96 degrees Celsius or 100 degrees Celsius. I think either answer is probably fine, given that it's not totally clear. Write down the temperature of the liquid 2 minutes after heating. So if you go up to 2 and go across, it looks to me that at 2 it's right at 24, 28, 32. Looks like it's at 36 degrees after 2 minutes. Part D says find the time it takes for the temperature to reach 68. So go over here again. Let's see, 64, 68, and we go straight over. 68 appears to be 1.4 minutes by the, or sorry, 68, yeah, 0.4 minutes. Which is that 0.4? Yeah. 2 boxes, which 0.4 times 60 is 24 seconds. To reach 68 degrees. Part E says decide whether the liquid reaches 22 degrees Celsius during the 5-minute period shown. Like I said, each box is on the left is worth 4 degrees, so it looks like this thing gets real close to 24 degrees, but not 22. And while I'm sitting here, might as well answer F as well. Write down the room temperature. Well, the room temperature is just this this horizontal asymptote right here, which is 24. So this thing is going to approach 24 degrees Celsius, but it'll never get below 24 degrees because every exponential function has a horizontal asymptote. So E, the answer is no, it doesn't get there. The room temperature then is 24 degrees Celsius. Alright, I want to talk about number 7 next, where we actually have to draw a graph. That one was interpreting the graph. Next one we're going to draw a sketch of a graph. Number 7 here. The functions f and g are defined by f of x equals 1 plus 4 over x, where x is a real number, not equal to 0, because it's rational, so 0 is not in the domain, because you cannot divide by 0. And g of x equals 3x, where x is a real number. Sketch the graph from -8 to +8. So I'm going to draw that sketch right here. And right there. Always label your x and y, and we're going to take this thing from +8 over to -8. Now, when I do this, I like to let the calculator do most of the heavy lifting. So I'm going to y equals, and in y1 I'm going to type in 1 plus 4 over x. y2 I'm going to type in 3x. Now, you should always go to the window and modify the window to match the requirements they gave you. In this case, the requirements they gave you is x has between -8 and +8. They made no specification on the y, so I'll just keep it at the default -10 to 10 right now. And let's just see if I can see everything. There's my rational, I can see all that, and there's my linear. So I'm feeling pretty good. Looks like this linear crosses twice. So I'm just going to pull this calculator off to the side here, and I'm going to try and make a rough sketch of it. Doesn't have to be perfect, but I know that the rational, there's some asymptotes, so this thing's going to approach but not touch the x and y axes. And there's also this linear function cut through here. Now I think you should always label the function, so this one's f of x, so is this, and this guy right here is g of x. And then I like to put dots where they intersect, because when things cross, we're usually going to be asked about where they cross. But there, that's a pretty rough sketch, but it gets the idea across. Oops, I forgot to label my y-axes. That was from 10 to negative 10. Got to have scale on both axes, so put some numbers on there for your sketches. Write down the equations of the vertical and horizontal asymptotes for f. Well, the vertical is easy. You can see that it's x equals 0 for the vertical asymptote. The y equals, or the horizontal asymptote, may not be as clear from this picture. So I'd always recommend you default to the equation. In the equation, there's a constant. That one right there, that tells you where your horizontal asymptote is. So that's y equals 1. And it's probably a good idea to go ahead and put that in your sketch as well. I usually just use a dashed line to signify that it's an asymptote. And that's just at 1. So y equals 1, there's a horizontal asymptote. At x equals 0, there's a vertical asymptote. Okay. Sketch the graph of g on the same axes. I already did that. Hence, or otherwise, find the solutions of 1 plus 4 over x minus 3x equals 0. So what's happening here? What's happening is they set these two equations equal to each other and then just simply subtract 3x over to the other side. So this is just a really funny way of asking, hey, these two functions cross twice. What are the coordinates where they cross? Not the coordinates, because it says find the solution, so really we just need the x values. So let's get those x values by doing second trace 5, enter, enter, enter. Oops, enter, oh goodness. Second trace 5, get pretty close to that intersection point, enter, enter, enter. That first value of x is 1.33333333. That's just x equals 4/3. Now again, because of the phrasing here, it doesn't say find the coordinates where they cross. I'm not concerned about the y value. I'm only concerned about the x, because it says find the solutions for this thing that only has x's in it. And second count 5, go over to the other side, enter, enter, enter. The other value of x is -1. So the two values of x that are the solutions to this equation are 4/3 and -1. You could have solved that algebraically too, but I don't recommend it. Write down the range of the function f. So the function f is this rational function here, and it looks like it's every single value of y except this horizontal asymptote, y equals 1, because the function never crosses y equals 1. So there's a couple ways to write that. Probably the most formalized way you could write it is you say, okay, it goes from -infinity to 1, it goes from 1 to positive infinity. It's not square brackets because they don't touch, and then we have to say it's the union of these two sets. That's the entire range. It's kind of a longhand way to write it. I think the easiest way is to just write, well, y does not equal 1. Either form is acceptable as far as I'm concerned. I asked you all to give me 2 problems, and then it only took me 10 minutes, so I'm going to go ahead and do number 8 while I'm down here, which is good, because I've hit 2 of the 3 subtopics. Subtopics 6.5 and 6.6 are about drawing and interpreting graphs. 6.7 is about seeing where graphs cross, which happens to be this last one right here. Let's go ahead and hit it while I'm sitting here, and this will be the last one we do. The diagram shows the graphs of the function y equals 5x squared and 3 to the x, the values of x between -2 and 2. Find the coordinates of the point of intersection of the 2 curves. Write down the equation of the horizontal asymptote of the exponential function. Let's do part B first because it's easy. You can see this exponential function here. It's approaching the x-axis, so the horizontal asymptote is pretty clearly going to be y equals 0. And you can verify that from the equation of the exponential. It says 3 to the power of x, but what it really says is 3 to the power of x plus 0. So that means my horizontal asymptote is y equals 0. Now for part A, see where these things cross? It looks like it crosses once, twice. But I want to let the calculator do all the heavy lifting, so I'm going to go ahead and type both these functions into y equals. And the first one is 5x squared, the second one is 3 to the power of x. I'm going to change my window because it's only from -2 to +2. And it looks like the y's that they've got here start at 0. And I don't know how high it goes, so I'm just going to leave it at 10. There's the parabola. There's the exponential. I see it crossing twice. Let's get those points of intersection. Second calc 5. Enter, enter, enter. The negative one is, and we'll just go to 3 significant figures here. Part A would be -0.365, comma 0.669. That's that first one. Second calc 5. Move the spider over to get on top of the other intersection points. So I'm just moving it really, really close right there. Enter, enter, enter. That's going to be 0.633, comma 2.01. 3 significant figures. Alright, that's it. Thanks for watching. I guess we won't have another video until next semester, so see you next time.